Getting into shape. Skill 8. Must be fate. Surface area of prisms. A prism is a 3D object which has a uniform cross-section. What that means is that the shape at each end of the prism is exactly the same size. For example, if we have a triangular prism here, the triangle at the front and the triangle at the back are exactly the same. That means that if we were to slice the prism up, like with this knife here, all of these triangles, if you slice through, are exactly the same size. They might vary in terms of how thick the slices are, but all of the slices have the exact same triangle shape. Some other examples of prisms are a cube. Now a cube is special in that it has exactly the same size square on every single side. A rectangular prism has the same rectangle front and back, and a cylinder has the same size circle top and bottom. The objects in the bottom right hand corner are not prisms. The reason we can tell that is that it doesn't have the same size shape in the top, to the bottom and through the middle. When we're finding the surface area of a shape, that's always in units that are squared because surface area is two-dimensional. Cubes, which are square prisms, have exactly the same size square on each of the 6 sides. Rectangular prisms have 6 sides which can be sorted into 3 pairs. Top and bottom, left and right, front and back. I'll show you this in the example below. Here we've got a pink rectangle at the front with the letter M. If there was a back rectangle that we could see in pink as well at the back, it would be exactly the same as the rectangle at the front. The rectangle on the right, which is the letter A, will be exactly the same as the rectangle on the left. And the rectangle on top, the letter E, will be exactly the same as the rectangle on the bottom. So there's 3 clear pairs. A surface area formula for a cube is 6 times L squared. The surface area formula for a rectangular prism is a bit more complicated. It's 2 lots of length times width plus length times height plus width times height. You can see here there's 1, 2, 3 combinations because we have 3 different pairs. If you need to find out the area of an individual square, you still use length squared. And if you need to find out the area of an individual rectangle, it's still length times width. Cylinders have a circle at the top and a circle at the bottom. There's also another section of a cylinder which is the middle. If you imagine that you have a can of tomato soup, if you were to peel off the label around the middle, it would form a rectangle. So when you find the surface area of a prism, there's a circle on the top, a circle on the bottom, and a rectangle in the middle. The formula for the surface area of a cylinder is 2 times pi times r, and then open brackets r plus h, where r is the radius and h is the height of the cylinder. If you need to find the area of an individual circle, you can still do that with the formula pi times r squared. And if for some reason you needed to find the area of just the label section of the can, so the rectangle we were speaking about, that would be found using 2 times pi times r plus h. Triangular prisms have 5 sides. These include 2 identical triangles, which are at the front and the back, and 3 rectangles. The rectangles can vary depending on the type of triangular prism you've got. The example on the left here shows a triangular prism where all sides of the triangle are 4 centimeters. So our true triangles at the front and back are always identical. These ones have 4 at the base and 3.5 centimeters for the height. The 3.5 centimeters is circled in red to make it clear for you. Now we have 3 rectangles. All of these rectangles are the same. They're all 4 centimeters because all of these lengths are 4 centimeters, and they're all 18 centimeters long because it's 18 from the front to the back. So number 1 rectangle, number 2 rectangle, and number 3 rectangle are all identical, all 18 by 4. If you want to find the total surface area, there's no formula. You just need to find the area of each rectangle, 1, 2, and 3, and the area of each triangle, 1 and 2. If they're the same, you can find the area of one rectangle and then multiply it by 3, but they won't always be the same. Like in this example on the right hand side, here we have 2 triangles which are the same, front and back, which have 7 on the bottom and 15 as the height. They're the same. But we've got 3 different rectangles this time. One is 7 by 17. That's this first one here, number 1. The next one, which uses the length 18 by 17, is rectangle number 2. The last one, which uses the red length 15 by 17, is rectangle 3. So the lengths that change are the ones around the triangle. 7 goes to this one here, rectangle 1. 18 goes to this one here, rectangle 2. And 15 goes to this one here on rectangle 3. But they all have 17 because 17 is the distance from the front to the back. Skill 8 done. Splash!